There's a certain comfort in knowing that some things on Earth feel eternal, unchanging, vast, and dependable. The Atlantic Ocean has always been one of them. It's a colossal force, stretching from the icy tips of the Arctic to the warm tides that kiss the equator. For centuries, it's been the backdrop to exploration, migration, and mystery. But recently, that sense of permanence has started to waver. Behind the crashing waves and endless blue, something has changed. And experts, those who spend their lives studying the rhythms of the sea, are beginning to say what few dared to before: the Atlantic Ocean is acting strange. It started quietly. A few scattered anomalies in temperature readings, odd weather patterns drifting off the coast, and whispers from fishermen claiming they were seeing things they hadn't seen in decades, or ever. At first, it was easy to dismiss. After all, oceans shift and move in cycles, right? But this wasn't just another ripple in a long-term pattern. The signs kept coming. Data didn't line up. Storms brewed faster. Currents meandered in unexpected ways. Something was off, and the more scientists looked into it, the more unsettling the picture became. The feeling now is one of uneasy curiosity, mixed with a growing sense of urgency. Research stations are reviewing years of past data, satellite teams are rechecking thermal scans, and deep-sea probes are being deployed to places once considered stable. Behind closed doors, conversations are turning cautious. Words like unprecedented, unusual, and even irreversible are showing up more frequently in scientific briefings. No one is saying we're on the brink of disaster, not yet. But for the first time in recent memory, there's a genuine question looming in the minds of many: what, exactly, is happening beneath the surface of the Atlantic? There's a growing belief that the changes we're seeing now are only the beginning. That what lies ahead could reshape coastlines, alter climates, and disturb life both above and below the waves. This isn't about one isolated event. It's about a string of subtle signals that, when strung together, paint a picture no one expected to see so soon. And perhaps the most unsettling part? Much of it is still hidden, buried deep below thousands of meters of cold, dark water, where humanity can only scratch the surface. As we explore the strange developments unfolding in the Atlantic, we'll uncover whispers of a shifting current, vanishing marine species, and mysterious disturbances in the deep. Some of these changes are rooted in science. Others are still unexplained. But all of them point to one chilling truth: something is stirring in the heart of the Atlantic Ocean, and it may already be too late to stop it. In the vast, blue expanse of the Atlantic Ocean, where the horizon seems to stretch forever and the waves rise and fall like the breath of the earth itself, something ancient has begun to change, something subtle, yet immense. It's not the kind of shift that grabs headlines or causes alarm bells to ring across the world. There are no dramatic visuals, no satellite images of destruction, no sudden environmental collapse. Instead, it's the kind of change that whispers, slowly and steadily, through deep ocean currents and delicate temperature gradients. It's a slow pulse beneath the surface, a powerful rhythm of nature that is beginning to falter. And that rhythm is the Atlantic meridional overturning circulation, or as scientists call it, the amok. Most people go about their lives without ever hearing about the amok. It doesn't make the news like hurricanes or wildfires do, and there's no simple way to visualize what it does. But despite its low profile, the amok is one of the most vital components of the Earth's climate system, a vast and intricate conveyor belt of ocean water that stretches thousands of miles from the equator to the poles and back again. It operates continuously, moving warm surface waters from the tropics up toward the North Atlantic, where the water cools, sinks, and flows back toward the south in the deep ocean. This endless circulation transfers an astonishing amount of heat across the globe, regulating temperatures, shaping weather systems, and helping maintain the delicate balance that life depends on. Think of the amok as a great hidden engine, one that works silently beneath the waves, influencing everything from rainfall in the Amazon to winter storms in Europe. And for thousands of years, this engine has run with remarkable consistency, like the beating heart of the ocean. But now, that heartbeat is starting to change. Recent observations from oceanographers and climate researchers are pointing to a troubling trend. The amok appears to be slowing down. Not by a lot, not yet, but enough to catch the attention of scientists who study the long-term rhythms of the planet. At first glance, the change might seem imperceptible. The ocean still looks the same from above, blue and endless, with waves rolling into shorelines around the world. Tourists still stroll along beaches, unaware that anything is different beneath their feet. But deep down, the flow is weakening. Instruments placed far below the surface have begun to pick up on subtle shifts in temperature, salinity, and current speed. These data points, collected over time and across vast distances, are painting a picture that many hoped they wouldn't see, evidence that this critical system is becoming more unstable, more erratic, and potentially less capable of doing the job it's always done. To put it simply, the amok is acting differently than it has in the past. And while climate models have predicted that a weakening was possible, especially as polar ice melts and adds fresh water to the North Atlantic, the pace of change seems to be faster than expected. Some researchers now believe we may be witnessing the beginning stages of a much larger disruption. If this circulation continues to slow, or if it eventually collapses altogether, the effects wouldn't be limited to the ocean. They would cascade into the atmosphere, the continents, and even the global economy. Places that rely on stable weather patterns could see dramatic shifts, droughts in some regions, floods in others. Europe could experience harsher winters. The southeastern United States could see intensified heatwaves. And tropical regions might suffer from unpredictable monsoon seasons or food shortages due to changing rainfall. But even now, with data accumulating and models evolving, there's a strange quietness to it all. The amok doesn't send out warning signs like a volcano or an earthquake. There's no sudden moment where it becomes obvious that something has gone wrong. Instead, the signals are scattered. Tiny anomalies in sea temperature here, unexpected salinity levels there, or drifting timelines in seasonal weather patterns. It's like watching a familiar melody slowly fall out of tune. You can't quite say when it started, but once you notice it, you can unhear it. One of the reasons this slow drift is so alarming is because of what we've learned from the past. Ice core records and deep-sea sediment samples reveal that the amok has experienced major shifts before, during periods when Earth's climate entered phases of extreme instability. In some cases, the changes were rapid, unfolding over decades rather than centuries. And when they did, the world above responded with dramatic consequences. Glaciers surged, coastlines shifted, ecosystems collapsed. Now, as scientists compare today's data with those ancient markers, a chilling thought is emerging: the fingerprints of the past are beginning to reappear in the present. Many point to the accelerated melting of Greenland's ice sheet as a major contributor to this imbalance. As more fresh water pours into the North Atlantic, it dilutes the salty ocean water, disrupting the delicate density balance that drives the circulation. Salty water is heavier and sinks more easily. Fresh water, on the other hand, is lighter and resists that downward pull. With enough dilution, the entire engine can begin to sputter. It's a small change in composition, but one with enormous implications for the entire system. And that's what makes this moment so unnerving. This isn't the result of a single catastrophic event, it's the culmination of small, sustained changes over time. Like a slow leak in the foundation of a house, it can go unnoticed until the structure starts to shift. And by then, reversing it may be impossible. For now, scientists continue to monitor, measure, and model. They compare results, run simulations, and share warnings with quiet urgency. But for most people, the Atlantic Ocean will continue to look the same: vast, mysterious, and serene. Beneath its surface, however, something ancient and powerful may be preparing to change. And if it does, we may one day look back and realize that this subtle shift was the first true sign that the planet's balance was beginning to tip. And what makes all of this so unnerving is how fragile it now appears to be. Recent studies show the amok is slowing. That may sound small, maybe even harmless. But in a system that has remained relatively stable for thousands of years, even a small change in pace can signal a much larger problem. Picture a grandfather clock, one that's been ticking steadily for centuries. If the tick slows by even half a second, it might seem minor. But in a mechanical system, Any deviation can mean something is off. Now imagine that clock isn't just keeping time, it's keeping balance for the whole house. The floors, the doors, even the lighting, all connected to that one ticking motion. If it falters, everything else feels it. That's what we're dealing with when we talk about the amok. It's not just an ocean current, it's the backdrop to a stable world. And right now, that backdrop is shifting. The reason for this change lies in the very things we've been doing to the planet for generations. As global temperatures rise, the polar ice sheets are melting at a rate never seen before in recorded history. Greenland, in particular, is losing hundreds of billions of tons of ice every year. That meltwater doesn't just vanish, it pours into the North Atlantic, spreading out like a veil of fresh water across the ocean's salty surface. But this is where things get tricky. The amok depends on dense, salty water to sink in the far North Atlantic. Fresh water, being lighter, interferes with that sinking motion. It slows it. It disrupts it. It changes the entire flow of the current. Over time, more meltwater means less sinking. Less sinking means less movement in the current. And less movement in the current means less heat transported north, triggering a cascade of consequences. Now, imagine this slowing continues. The tropical waters stay warmer than usual, while the North Atlantic becomes colder. That difference in temperature can start changing atmospheric patterns. Jet streams, those fast, high-altitude rivers of air that guide our weather, may start to wobble. Storm systems could become more erratic. Some areas might see stronger hurricanes fueled by warmer waters. Others could plunge into deeper droughts or unseasonal cold. The planet would still spin, the oceans would still move, but the predictable patterns we've relied on could start to unravel. What makes the situation even more complex is the time scale. The amok doesn't change overnight. It doesn't collapse in a week or even a year. It slows inch by inch, year by year, quietly, like a tide turning in slow motion. And that slowness is part of the danger. Because by the time the signs become obvious to the general public, it may be too late to reverse them. This isn't a problem we'll see coming like a flash flood or an earthquake. It's more like a long fuse burning silently in the background. And yet, for all the science and warning signs, much of the world remains unaware. That's not because the information isn't there. It's because the amok is hard to visualize, hard to feel in everyday life. You can't walk outside and see the currents slowing down. There are no bright red alerts on your phone. No immediate consequences on your morning commute. But behind the calm surface of your day-to-day life, the ocean is quietly changing course. And that change could rewrite the rules we've long taken for granted. Consider this. Scientists analyzing ancient ice cores and sediment layers have discovered moments in Earth's past when the amok shut down completely. Not just slowed, but stopped. The results were dramatic. Northern Europe plunged into sudden and intense cold. Droughts swept across the tropics. Whole ecosystems reshaped in just a few decades. It's like flipping a switch and watching the world tilt into a different climate regime, not over millennia, but in the span of a human lifetime. While we're not at that point yet, the signs of a potential tipping point are growing harder to ignore. The concern now is that we may be edging closer to a threshold, one where the current can't recover on its own. Like pulling too many threads from a tightly woven fabric, there comes a point where the whole thing begins to unravel. And if that happens, the amok may enter a new, less stable state, one that could persist for centuries. We're standing at a crossroads, where the actions we take, or don't take, could influence whether this vital current continues to function or begins to fade. The ocean isn't sounding an alarm, but the data is. The models are. The researchers watching every drop of meltwater and every shift in current are raising their voices, even if the world isn't yet listening. What's unfolding in the Atlantic is not just a scientific curiosity, it's a slow-moving signal of deeper change. A reminder that the systems we depend on are vast, interconnected, and vulnerable. And that sometimes, the most important warnings don't come with a bang, but with a whisper from beneath the waves. Now, let's talk about the rapid melting of Greenland's ice sheet. High above the Atlantic Ocean, nestled near the top of the world, Greenland stands like a frozen giant, vast, quiet, and ancient. This icy landmass, coated in a sheet of white that stretches as far as the eye can see, might seem remote and detached from everyday life. For centuries, it has been almost mythic in its isolation, a place of glaciers and snowstorms, of towering ice cliffs and endless silence. But in recent decades, that silence has started to break, not with a roar, but with a slow, persistent drip. One melt at a time, Greenland is changing, and with it, the world. The Greenland ice sheet is enormous, second in size only to Antarctica. It's so massive that if you stood in the middle of it, you wouldn't be able to see the coastline in any direction, just ice and sky. It holds enough frozen water to raise global sea levels by over 7 meters, or about 23 feet, if it were to melt completely. That's not just enough water to cover a beach, it's enough to permanently flood entire cities. New York, Miami, London, Mumbai, all would be dramatically reshaped. But what makes this even more alarming is that the melting is already underway, and it's not slowing down. Each summer, as temperatures rise, Greenland experiences a natural melt season. Some melting is expected, it happens every year. But in the last few decades, scientists have observed that this melt season is becoming more extreme, more prolonged, and more widespread. Areas that once remained frozen year-round are now experiencing regular thawing. Rivers of meltwater are carving their way through the ice, plunging deep into the glacier like underground waterfalls, lubricating the base and accelerating the flow of ice into the ocean. This isn't just surface melting, it's structural. To the untrained eye, it might not seem like a big deal. After all, what's a bit of melting in a place that's still mostly frozen? But here's where the ripple effect begins. When ice melts on Greenland, it doesn't just stay there. That water has to go somewhere, and it flows into the ocean. Each drop contributes to rising sea levels, a process that affects coastlines thousands of miles away. It's like adding spoonful after spoonful of water to a full glass. It doesn't take long before it starts to overflow. In fact, Greenland alone is currently responsible for roughly 25% of global sea level rise. That's not a hypothetical number, it's happening now. And the volume of ice being lost each year is staggering. Some estimates suggest that over 250 billion tons of ice are melting from Greenland annually. That's equivalent to over 400,000 Olympic swimming pools of water being dumped into the ocean every single year. And as global temperatures continue to climb, that number is only expected to rise. But the story doesn't stop at rising seas. As Greenland melts, it's also sending a massive pulse of fresh water into the salty North Atlantic Ocean. This is critical, because the ocean's currents, particularly systems like the amok we discussed earlier, depend on a delicate balance of temperature and salinity to keep flowing. Fresh water is lighter and less dense than salt water, and when too much of it floods the ocean's surface, it begins to disturb that balance. It acts like a lid, preventing cold, salty water from sinking and thereby weakening the engine of deep ocean circulation. That means the melting ice sheet isn't just a local problem for the Arctic, it's a global disruptor. Coastal cities are already beginning to feel the effects. In places like Jakarta, Bangkok, and New Orleans, sea levels are rising faster than infrastructure can keep up. Salt water is seeping into farmland and freshwater supplies, making it harder to grow crops or find clean drinking water. Flood defenses designed for older sea level predictions are being overwhelmed during storms. Tides are becoming more aggressive, eroding coastlines and flooding neighborhoods more often, even without hurricanes. And it's not just physical damage. These changes also bring economic pressure, displacement, and a growing number of climate refugees, people forced to leave their homes not because of war or famine, but because the sea simply keeps rising. Meanwhile, the loss of Greenland's ice is changing the very shape of the land itself. As the weight of the ice lessens, the bedrock beneath it begins to rise, a process known as glacial isostatic adjustment. It's like taking your hand off a sponge. It slowly lifts back up. This shift alters gravitational fields, which in turn affects ocean currents and sea levels around the world. That's right. The melting of ice in one corner of the globe can literally change sea levels unevenly in other regions, based on the gravitational pull and the reshaping of the Earth's crust. And yet, even with all these warning signs, the melting of Greenland can still seem distant. After all, most of us don't live in the Arctic. We're not walking on glaciers or watching icebergs break off into the ocean. But the effects of this distant melting are steadily creeping closer. Whether it's higher tides during a storm, more intense rainfall, or unexpected changes in local weather patterns, these subtle shifts are all connected. We often think of global warming as something gradual, something far off in the future. But Greenland's story tells us a different tale, one of now. One of cascading effects that have already begun. And if this much change is happening while only a small portion of the ice sheet has melted, we have to ask, what happens if it continues? What if this pace accelerates? While the physical melting of Greenland's ice sheet is striking on its own, what truly surprises scientists is the unintended chain of events set in motion by that melt. This isn't just a one-step process where ice melts and sea levels rise. It's a domino effect, a cascade of interactions that touch everything from weather systems to wildlife, all connected in ways we're only beginning to fully grasp. As fresh water from the melting glaciers pours into the ocean, one subtle but powerful change begins to unfold in the atmosphere above. The Arctic region is warming at more than twice the rate of the global average, a phenomenon called Arctic amplification. This rapid warming doesn't just stay up north. It creates strange disturbances in the jet stream, a fast-moving river of air that flows high above us and helps guide the path of storms and weather systems. When the jet stream weakens or becomes wavier due to shifting temperatures in the Arctic, weather patterns can get stuck in place. This can lead to long, drawn-out events like heatwaves that won't end, rainstorms that linger for days, or cold snaps that dive unusually far south. So, in a very real way, what happens in Greenland can directly impact the weather outside your window, even if you live thousands of miles away. The melt is changing the engine room of the planet, and those changes ripple outward in unpredictable ways. Meanwhile, on the ground in Greenland itself, the melting is uncovering landscapes that haven't seen the sun in thousands of years. As ice recedes, new terrain is revealed, bare rock, ancient soil, and forgotten ecosystems. This might sound exciting at first, like a new frontier being uncovered. But the implications are more complicated. When these newly exposed areas interact with rain, sunlight, and the atmosphere, they begin to affect the carbon cycle. Some of these landscapes contain organic material, plant matter, animal remains, and ancient soil that has been frozen in time. As they thaw, they begin to decompose, potentially releasing methane and carbon dioxide into the air. These greenhouse gases, once locked safely away under the ice, now enter the atmosphere and contribute to further warming, a feedback loop that could speed up climate change even more. It's like opening a sealed vault that had been preserving the past, only to realize that its contents could endanger the future. At the same time, the melting landscape is also affecting local ecosystems. Creatures that depend on ice, like polar bears, seals, and certain bird species, are seeing their habitats shrink and their food sources become more scarce. But even creatures we don't think about often, like microorganisms and algae, are playing a part in this story. As meltwater flows across the ice sheet, it carries with it nutrients and sediments that feed blooms of dark-colored algae on the ice's surface. These tiny organisms may seem harmless, but they're changing the ice's ability to reflect sunlight. Clean ice is brilliant white. It bounces sunlight back into space like a mirror. But when it's coated with algae or soot from wildfires and distant pollution, it darkens. This darker surface absorbs more heat, which speeds up the melting process even more. Again, we see another feedback loop. The more it melts, the more it melts. It's a cycle that feeds on itself, quietly but relentlessly. And then there's the human side of the story. The indigenous communities of Greenland, many of whom have lived in harmony with this frozen world for generations, are seeing their way of life transformed. Thawing permafrost is making traditional hunting paths dangerous. Changing sea ice conditions make fishing less predictable. In some areas, buildings and roads are cracking as the ground beneath them softens. The very stability they once depended on, physically and culturally, is slipping away. Even nations far removed from Greenland are beginning to take notice. As the Arctic becomes more navigable due to melting sea ice, new shipping routes are opening, attracting global attention. Countries are racing to assert their presence in this emerging frontier, not just for trade, but also for natural resources like oil and minerals buried beneath the ice. What was once inaccessible is now suddenly in reach, and that raises big questions about sustainability, sovereignty, and the balance between economic opportunity and environmental preservation. In the span of just a few decades, Greenland has shifted from being a remote, icy backdrop in the global climate system to a key player in Earth's unfolding future. The changes happening there are no longer just scientific curiosities or background statistics. They're now shaping everything from geopolitics to grocery prices, from polar bears to power grids. And as we keep watching this frozen landscape evolve, one thing becomes clear: what happens in Greenland will not stay in Greenland. As our eyes remain fixed on the icy frontiers of Greenland, another drama quietly brews far below our feet. The ground itself is shifting, swelling, and rising in ways that have begun to stir both curiosity and deep concern among scientists. This time, the focus isn't on the polar extremes, but in areas where the Earth's crust is subtly changing, where the land seems to be lifting from beneath like something long dormant is awakening. It's a process called ground uplift, and while it sounds like a slow, harmless phenomenon, it's often a clue, sometimes the only clue, that something powerful is happening underground. One such place where this mysterious process has been drawing attention is a quiet yet geologically active region near volcanoes, fault zones, or long-forgotten magma chambers. In places like the Yellowstone caldera, researchers have been measuring the Earth's crust rising at a surprising rate, centimeters each year. Now, that might not sound like much at first glance, but in geological terms, it's a huge shift. The surface of the planet is not supposed to behave like a soft balloon gradually puffing up with pressure. When it does, it can mean that magma is on the move, or that gases are collecting beneath the surface, slowly forcing the land to expand outward like a warning breath before a much bigger event. What makes this so intriguing and unsettling is how silent and invisible it all is. There's no smoke, no eruption, no rumbling tremors. Just a slow, persistent bulge. The only way scientists even know it's happening is through satellite data and ground sensors, advanced tools that can track changes in elevation down to the millimeter. These instruments, quietly orbiting or embedded in the Earth, whisper warnings in data streams: the land is rising, something is building. But the true cause, the exact timeline, the potential consequences? Those remain elusive. And that uncertainty creates a mixture of fascination and unease. Ground uplift doesn't always lead to eruptions or earthquakes, of course. In many cases, it's part of a natural breathing cycle within the Earth, an inflation and deflation that may not result in any dramatic surface event. But it's the unknowns that make it worthy of attention. When researchers spot uplift in historically active areas, regions with a past of violent eruptions or massive quakes, they pay close attention. Even a small rise might hint at a reawakening of ancient geological forces. Take, for instance, the townships and remote valleys built atop what was once lava flows or ash fields. To most people, these are just scenic backdrops, lush forests, rolling hills, perhaps even tourist destinations. But beneath some of these landscapes are sleeping giants, volcanic systems that have been quiet for hundreds, even thousands of years. As the ground begins to rise, it invites an unsettling question: is it finally time for one of these systems to stir again? In places like Italy's Campi Flegrei, one of the most closely watched supervolcanoes on Earth, ground uplift has become a critical indicator. This massive caldera, which last erupted in 1538, has shown signs of inflation for decades. What was once just a minor inconvenience for locals, roads cracking, sidewalks buckling, is now part of a growing concern among geologists. The uplift there is not only persistent, but accelerating. Residents and researchers alike are watching and waiting, trying to interpret what the Earth is telling them. And that brings us to a larger truth: the ground beneath us is not as stable as we like to believe. We walk, build, and plan as if the Earth is unmoving, solid, dependable. But in reality, it's a restless system of shifting plates, molten rock, and deep pressure zones that can change suddenly and without warning. Ground uplift is just one signal of this hidden world, an early whisper from the planet itself. What makes the topic even more compelling is how widespread it is becoming. It's not just limited to one hotspot. Similar patterns are emerging across the globe, in parts of Iceland, Alaska, Indonesia, and even remote regions in South America. Each site has its own story, its own rhythm, and its own level of risk. But they all share one thing in common: they remind us that the planet is alive and constantly evolving. What we see on the surface is only part of the picture. And yet, despite all the advanced monitoring and scientific knowledge, we're still largely guessing. Scientists can track the rise, measure the speed, compare it to past events, but the future remains uncertain. Will the pressure beneath the surface release gently over time? Or will it erupt in a sudden, violent expression of nature's raw power? These are the questions being asked behind the scenes in university labs and geological institutes, where experts study satellite data with furrowed brows, trying to piece together the clues before it's too late. When the Earth's surface begins to bulge upward, what we're often witnessing is a chain reaction deep underground, a slow buildup of geological pressure that is invisible to the naked eye but potentially explosive in its consequences. One of the key drivers of this ground uplift is the accumulation of magma, molten rock rising from the mantle and collecting in chambers miles beneath the surface. This magma doesn't always push straight to the top. Instead, it pools and builds, causing the land above it to stretch and swell like a balloon being gradually filled. It's a process that can take weeks, months, or even decades, and the unsettling truth is that by the time visible signs emerge, the system underneath has often already been stirring for a long time. This subtle pressure buildup is not a straightforward alarm bell. That's what makes it so challenging. In some cases, the ground may inflate steadily for years without a single eruption. In others, uplift may remain dormant for ages, until suddenly, with little warning, the pressure tips the balance. Think of it like bending a metal bar slowly over time. It may look unchanged at first, but eventually, a point comes where it snaps, not because of sudden force, but because of the long, unseen stress building within. Ground uplift tells a similar story, one of long-term stress accumulation in the Earth's crust. And the Earth is not uniform. Different regions respond in different ways to this underground pressure. In some areas, like calderas and supervolcanic systems, the rock above the magma chamber is brittle and fractured, more likely to allow gases and fluids to escape. This can result in inflation-deflation cycles, where the land rises and falls repeatedly as magma and gas shift in and out of the chamber. In other areas, the crust is thicker and more resistant, meaning the pressure can build to much higher levels before any kind of release, making it both more stable in appearance and more dangerous in potential. What complicates matters even further is how difficult it is to predict the final outcome. Scientists use a variety of tools: satellite-based interferometric radar, (SAR), GPS sensors, seismometers, and gas emission detectors, to piece together a picture of what's happening underground. But these tools can only observe the symptoms, not the cause. They tell us the land is rising, yes, but they don't always reveal whether it's magma pushing upward, water and gas expanding underground, or tectonic pressure from deeper faults. In many cases, multiple factors are working in tandem, creating a murky and ever-changing situation. Consider how this plays out in regions with large populations. Areas that show signs of uplift are not always remote wilderness zones. They often lie beneath towns, cities, and critical infrastructure. In such places, the effects of uplift are not merely geological, they're deeply human. Roads begin to crack, buildings shift slightly on their foundations, and residents start noticing strange changes in the terrain. The changes may be minor at first, barely worth a headline, but over time, they accumulate. And without clear answers from experts, the population is left with a growing sense of unease. In parts of Latin America, for example, ground uplift has quietly reshaped entire landscapes. Villages built atop ancient lava fields have begun to rise in uneven patches, warping roads and tilting buildings as if the earth is slowly breathing beneath them. In some cases, the cause remains unclear, even after months of investigation. Is magma returning to long silent chambers? Are tectonic stresses being redistributed after years of dormancy? These are the puzzles that geologists face, often with limited resources and even more limited data. And the phenomenon isn't always tied to volcanic systems. Ground uplift has also been observed in non-volcanic zones, where the primary cause appears to be hydrothermal activity, the movement of superheated water and gases through subterranean pathways. This can create uplift without magma, especially in areas with complex geothermal systems. Over time, pressure builds as fluids are trapped and expand, pushing the land upward. In some of these areas, the risk isn't eruption but rather ground instability, sudden sinkholes, surface cracks, or subsidence when the pressure abruptly shifts or is released. What adds a layer of tension to all of this is how little public awareness there is about ground uplift. It's not a flashy disaster like a sudden earthquake or a dramatic volcanic eruption. It unfolds slowly, almost silently, in the background. But it is precisely that slowness that makes it dangerous, because by the time it finally draws wide attention, the critical moment may already be near. And unlike storms or floods, there's no visible buildup. The signs are quiet: a few centimeters of elevation change, a subtle distortion in satellite radar images, a slightly warmer temperature in underground gas vents. In this way, ground uplift challenges how we think about natural threats. It doesn't conform to our sense of urgency. It doesn't roar or rumble until it's almost too late. Instead, it waits. It builds. It reminds us that not all dangers come with a warning siren. Some arrive quietly, patiently, through the shifting of the ground beneath our feet. In areas experiencing ground uplift, local communities often find themselves dealing with a rapidly changing environment. Infrastructure such as roads, bridges, and buildings that were once stable begin to show signs of strain as the ground beneath them slowly shifts. Roads that were previously smooth become uneven, creating hazards for drivers. Cracks appear in foundations, making buildings unstable over time. Even more critical are the effects on water systems. Pipes, reservoirs, and canals may be displaced or ruptured as the land rises. In some cases, the pressure beneath the surface can even trigger localized flooding, further complicating the situation. For communities that rely on stable ground for daily life, this can be a literal and figurative shift that threatens their way of life. In regions near active volcanic systems or other tectonic hotspots, the process of ground uplift is not isolated. It's often part of a broader chain of geological events that affect the entire area. While uplift may be gradual, the underlying forces are usually tied to tectonic shifts, which can lead to increased seismic activity. Small tremors may occur alongside the uplift, or in some extreme cases, larger earthquakes may follow. Even though these quakes might not always be strong enough to cause widespread destruction, they can be unsettling for local populations, especially if they are frequent. The tremors, combined with the rising ground, create a compounding threat, one that cannot be easily prepared for because of the uncertainty surrounding when or how major events will unfold. Another crucial aspect of ground uplift is its potential to disrupt agriculture and natural resources. In rural areas where farming is the backbone of the local economy, even minor shifts in the landscape can cause major problems. Irrigation channels and fields can become misaligned, requiring expensive repairs and potentially resulting in crop failures. In areas where communities depend on natural resources, such as rivers or underground aquifers, the land's movement can alter the flow of water or change the composition of the land itself, making it harder to access clean water or fertile soil. The effects of this can cascade, impacting food security and local economies that may not have the infrastructure to cope with such dramatic changes. The question of emergency preparedness in regions at risk for ground uplift becomes even more pressing. While the phenomenon is not always associated with immediate disasters like volcanic eruptions, the subtle and unpredictable nature of the uplift creates serious challenges for governments and humanitarian organizations. monitoring systems that track the rise of the land need to be in place, and evacuation plans for regions prone to the most severe effects must be tested and refined. Yet many of these systems are still underdeveloped in some of the most vulnerable areas, leaving communities exposed to unforeseen risks. Additionally, as the economic cost of these adjustments rises, local governments must balance their budgets and prioritize other pressing needs. Without robust funding and political will, the necessary action to mitigate these risks can be slow to materialize. Psychological stress on affected communities should also not be underestimated. The gradual nature of ground uplift can create a sense of long-term uncertainty. Residents may not face an immediate crisis, but the cumulative pressure of living on land that is slowly shifting can take a psychological toll. For many, this may lead to heightened levels of anxiety and stress, as the community feels increasingly powerless in the face of a geological force they don't fully understand. Families may be forced to make difficult decisions, such as whether to invest in strengthening their homes, relocating entirely, or simply hoping that the problem will not escalate. It's a dilemma that is complicated by the fact that the cause of uplift is often unclear. Without concrete explanations or predictions, people find themselves living in a constant state of geological suspense, wondering if or when the inevitable collapse might come. On a larger scale, the impacts of ground uplift on regional economies can be staggering. Displacement of populations, disruption of trade routes, and the loss of agricultural or industrial production can contribute to a widening economic gap. In some cases, entire industries may be affected. Tourism, for example, can be a major casualty in regions experiencing ground uplift. Areas that were once attractive to visitors because of their scenic beauty, stable infrastructure, and cultural sites may find that the rising ground causes irreversible damage to the tourism industry, as attractions become unsafe or difficult to access. The ripple effects of this loss can extend far beyond the tourism sector, touching everything from local businesses to government revenues. One of the most unsettling aspects of ground uplift is its lack of predictability. Unlike other natural disasters, which often offer some warning, whether through weather patterns, seismic activity, or shifting climate conditions, ground uplift can occur over such a long time span that foreseeing its impact with certainty is incredibly difficult. Even with all the technology at our disposal, scientists are still working to fully understand the intricate processes that drive this phenomenon. As a result, the communities living in these zones are forced to deal with a complex web of unknowns, including when and where the next significant uplift event might occur. The uncertainty surrounding this can cause social fragmentation, as local governments, private industries, and citizens struggle to balance the need for action with the reality that the exact nature of the threat remains unclear. Ultimately, while the rise of the land can seem like a slow-motion disaster, it's the unseen and unexpected consequences, the cracks in the infrastructure, the changes in local economies, and the emotional toll on residents, that can make it so insidious. It is not just about watching the earth rise in front of you, but also about understanding how that gradual rise can change everything: your home, your work, your family's safety. Ground uplift is a subtle but powerful reminder of how intimately connected we are to the forces beneath our feet. One of the most immediate environmental consequences of ground uplift is the alteration of natural habitats. As the Earth's surface rises, it can push entire ecosystems out of balance. Plant species that once flourished in a particular region may find themselves suddenly exposed to a new set of conditions. Uplift can change soil composition, affect water tables, and even shift local climate patterns. When the ground rises, areas that once received consistent rainfall or had stable temperature conditions might experience changes in water drainage, soil fertility, and temperature ranges. These changes can cause disruption in plant life, leading to the decline or even extinction of plant species that cannot adapt quickly enough. The wildlife that depends on these ecosystems faces similarly dramatic consequences. Many animals are highly adapted to specific environmental conditions, and even slight changes in temperature, water availability, or plant life can affect their survival. For example, birds that rely on particular tree species for nesting may find that those trees can no longer thrive in the uplifted ground. Similarly, animal species that depend on aquatic habitats could see their freshwater resources become inaccessible as rivers or lakes are altered by the rising earth. Even though some species are capable of migrating, the process is far from simple. Habitat fragmentation caused by ground movement can lead to isolated populations of animals, reducing genetic diversity and making the species more vulnerable to disease or other threats. One of the more concerning environmental impacts of ground uplift involves water systems. As the ground shifts, it can disrupt rivers, streams, and groundwater supplies, causing them to dry up or change course. This can have cascading effects on ecosystems that rely on consistent water flow, such as wetlands and forests. For instance, when an underground aquifer is cut off or redirected, local communities and wildlife that depend on it for drinking water or irrigation might find that their primary source is suddenly unavailable. If rivers become blocked by rising land, fish populations that depend on free-flowing waters for migration or breeding can be severely impacted. The hydrological cycle, which is already vulnerable to climate change, can be made even more unpredictable by land movement. In addition to this, coastal ecosystems are particularly vulnerable to ground uplift. Rising land can alter the relationship between the sea and the shoreline, changing tides, currents, and even the geography of the coast itself. For example, areas that were once rich in salt marshes, critical habitats for migratory birds and other coastal wildlife, may find those habitats disappearing as the land rises. The balance of saltwater and freshwater in estuaries can be upset, leading to the degradation of these vital ecosystems. Some of the most biodiverse ecosystems on Earth are in these coastal regions, and the impacts of ground uplift can be felt across a vast array of species, from tiny plankton to large marine mammals. But it's not just the immediate environment that suffers. Over time, the cumulative effects of uplift can lead to long-term ecological shifts. Erosion is one of the most common side effects of land movement, and it can rapidly degrade landscapes, especially in regions where uplift is more dramatic. As the Earth's surface rises, older soils that were once stable are exposed to the elements, often leading to accelerated erosion. This can strip the land of its nutrients, making it more difficult for vegetation to take root. The loss of soil fertility affects not only plants but also animals that rely on plant life for food. In turn, the erosion of fertile soil contributes to desertification, especially in regions that are already arid. The combination of rising land and decreasing soil quality can push entire ecosystems to the brink of collapse. Additionally, areas that are vulnerable to ground uplift often have unique geological features that contribute to their rich biodiversity. Uplift may expose previously inaccessible underground minerals or change the surface temperature in ways that affect both local plant life and animal populations. If these environments are altered too quickly, they may not have the time to adapt, resulting in the loss of entire ecosystems. For example, mountainous regions that experience sudden uplift could undergo a drastic change in vegetation zones, causing species that thrived at lower elevations to be pushed out by more robust plants adapted to higher altitudes. Over time, this could drastically alter the food chains and survival of both plant and animal species in the region. Lastly, climate change may interact with the effects of ground uplift in unpredictable ways. In some cases, areas that experience uplift may also find that local weather patterns change. Rising land could lead to changes in air currents or wind patterns, which in turn affects how moisture is distributed across the landscape. Regions that were once cool and wet might experience hotter, drier conditions, while others might experience more rainfall, leading to flooding or changes in vegetation growth. These climate shifts, combined with the structural changes caused by ground uplift, make it more difficult to predict how ecosystems will respond in the future. The compounded nature of these changes can push local ecosystems beyond their ability to adapt, leading to greater extinction rates and less biodiversity. These environmental consequences of ground uplift may seem abstract or far off for some, but they are already playing out in various parts of the world. Whether it's the gradual loss of biodiversity in upland regions or the erosion of coastal ecosystems, these changes are tangible and significant. The rising of the Earth's surface doesn't just affect human structures, it also impacts the delicate balance of nature. As we continue to witness ground uplift, it's important to understand not just how it changes the landscape physically, but also how it reverberates through the ecological web, leading to long-lasting consequences for both local wildlife and global biodiversity. As we begin to close our discussion on the rise of the land, it's important to remember that the Earth is not a static entity. It is constantly changing, shifting in ways that are often hidden beneath the surface. From the crust to the atmosphere, each layer of our planet plays a role in a larger, interconnected system. And while it may seem like something as simple as ground uplift is just a change in elevation, it is much more than that. This rising land is a direct consequence of the Earth's dynamic systems, particularly when we look at the impact of the melting ice sheets and the broader climate shifts they trigger. You see, as massive ice sheets in Greenland and Antarctica melt due to increasing global temperatures, the weight that once pressed down on the Earth's crust is lifted. This process, known as glacial rebound, causes the land to slowly rise again, as if the Earth is breathing a sigh of relief. But don't let the gradual nature of this process fool you. This rebound is happening faster than ever before due to the accelerated pace of climate change. In some regions, the rise of the land is happening at rates never seen in human history. And with this rise comes a whole host of consequences, both predictable and unpredictable. One of the most striking consequences is the disruption of the delicate balance between land and sea. As the ice sheets melt, the sea level rises, encroaching on coastal areas and flooding once dry land. But at the same time, the land itself is rising, creating a strange, often confusing push and pull between water and land. This dynamic interaction is one of the reasons why some coastal areas are seeing rapid changes, from more frequent flooding to the alteration of ecosystems that have been stable for thousands of years. Yet, the story doesn't end with just rising seas and shifting land. The melting ice sheets have a much broader impact on global systems, especially the ocean currents that regulate climate across vast regions of the world. Take the Atlantic Meridional Overturning Circulation, AMOC, for example. This vital current is what helps to maintain the climate in places like Western Europe and parts of North America. It is driven, in part, by the cooling of water in the polar regions, where the ice sheets melt and fresh water is added to the ocean. But when too much fresh water enters the system, it disrupts this delicate process, slowing the AMOC and possibly triggering a cascade of environmental changes. A slowdown or collapse of the AMOC could have profound effects on global weather patterns. Imagine longer, harsher winters in Europe, extreme weather events, and disruptions in agriculture that could lead to food shortages. These are just a few of the ripple effects that could be felt across the world. The rise of the land and the melting ice sheets are not isolated events. They are intricately linked to the larger patterns of global climate change. And as these processes accelerate, so too does the urgency to understand their implications. So, how do we respond? First and foremost, we need to acknowledge the interconnectedness of all these systems. The land uplift, the rising seas, the disruption of ocean currents, they are all symptoms of a larger issue at hand, climate change. And while we may not be able to reverse the effects of climate change overnight, we can take action to slow its progress and mitigate the consequences. From reducing carbon emissions to investing in sustainable technologies, every action counts. In addition to these global efforts, we must also focus on adaptation strategies. Coastal communities, in particular, are on the front lines of this battle. Protecting these areas from flooding, fortifying infrastructure, and ensuring access to fresh water will be critical as sea levels continue to rise. For those living in areas where the land is rising, we must understand how these changes affect ecosystems, human habitation, and agriculture. It is a delicate balance to strike, but one that can be managed with careful planning and foresight. As we look to the future, it's clear that the effects of the rising land and melting ice sheets are just beginning to reveal themselves. We are standing at a crossroads, where the choices we make today will determine how we live in harmony with our planet tomorrow. Understanding the science behind these processes is essential, but it's equally important to remember that these changes are not just happening in remote parts of the world. They are affecting us all, and it will take a global effort to confront the challenges they present. In the end, the rise of the land, the melting ice sheets, and the shifting of ocean currents all serve as stark reminders of the delicate balance that sustains life on Earth. These phenomena may seem distant, but they are intimately tied to the world we live in today. We must act now, with urgency and determination, to ensure that the forces of change do not overwhelm us. Together, we can chart a course toward a more sustainable, resilient future, where we protect not only our planet but the generations to come. If you've found this journey into the rising land and shifting ice sheets as fascinating as we have, don't forget to hit that like button and subscribe for more in-depth explorations into the forces shaping our planet. Your support helps us bring more thought-provoking content like this directly to you. Share your thoughts in the comments below. Let's keep the conversation going. Stay tuned for more, and remember, the Earth is always changing. Together, we can learn and adapt to these extraordinary changes.